So in today's lesson, we are going to revisit some algebraic techniques and then introduce some new algebraic methods. So we're going to start by recapping a little bit of work on expanding brackets. So we're going to start with a series of examples, and I would like you to, in each case, expand and then simplify the result. So here are your first 6 examples. Can you expand and simplify each of the following? Pause the video and spend 2 minutes doing this. So let's quickly check our answers. Question 1, nice and simple. We should have 14x plus 2. Question 2, we should have x squared plus 4x. Question 3, we should have 6x squared, subtract 2x. Question 4, we should have 10x squared plus 6xy. Question 5, 10 subtract 6, add 2x. Careful here with negative 2 multiplied by negative x, which simplifies to give us 4 plus 2x. And question 6, we have 2x minus 6 plus 4 minus 4x. And then collecting like terms together, we end up with negative 2x subtract 2. Now, we've also previously looked at how we expand and simplify 2 brackets. So, can you now please have a look at the following examples and simplify each of these carefully, expanding the brackets and collecting like terms. So here are your 6 examples. Have a go at expanding and simplifying in each case, and then check your answers afterwards. So here they are, answers coming up. Question number 1, we should find we get x squared plus 3x plus 2x plus 6, which simplifies to give us x squared plus 5x plus 6. I'm not going to put in this first step of working in most of the following examples. So, question number 2, we'll go straight to the final answer. X squared minus 3x minus 4. Question number 3, x squared minus 9x plus 14. Question number 4, don't forget that this is a pair of double brackets and must be expressed as such, giving us x squared plus 6x plus 9. Question number 5, we have 6x squared minus 2x plus 9x minus 3. I have put in the first step of working here as it's a bit more complex. So we end up with an answer of 6x squared plus 7x minus 3. And in question number 6, we have 2 pairs of expansions to complete. X plus 2 multiplied by x plus 2, subtract x minus 2 multiplied by x minus 2. We have to be very careful here because there are multiple negative signs. So the first pair of brackets that I've highlighted in yellow give me an answer of x squared plus 4x plus 4. And from that, we're subtracting, in green, x squared minus 4x plus 4. Notice how I'm keeping all 3 components of the green expansion together in a set of brackets. I'll highlight that set of brackets in red so you can see what I mean. Now, make sure you do the subtraction very carefully. X squared subtract x squared gives me nothing, cancellation. I then have 4x minus 4x, which gives me an 8x, and then to finish off I have positive 4, subtract positive 4, again cancellation, leaving me with an answer at the very end of 8x. Now you may or may not remember the vocabulary we've used in some of these examples, but an expression like this, and this is called a quadratic expression. Now, a quadratic expression will have as the highest power a square, so a power of 2. So you can see in this expression, for example, the highest power is x squared. So for instance, if you had an expression that looked like this would not be quadratic because there is an x cubed term. So this would be a cubic expression. And going up in powers, we can create different sorts of expressions. An expression that contains as its highest power an x to the 4 term would be called a quartic expression. If there was an x to the 5 term as the highest power, it would be a quintic expression. A little bit later on this lesson, we are going to be focusing in some detail on the concept of quadratic expressions. So we're now going to review the technique of factorization, and we're going to see whether we remember how to carry this out. So let's start with a few simple examples. I am going to factorize this. 12x minus 3y. So looking at the two terms, the only common factor we have here is a factor of 3. So outside the bracket we have 3, inside the bracket we need 4x minus y. And then always multiply back in your head, expand, or even write it down just to check that you revert back to the original question. So we get 12x minus 3y. Example number 2. This time we've got 24x subtract 8xy. Now, this time, look carefully at the 24 and the 8. Remember, you need to try and extract the highest common factor. So yes, you could take 2 out. Yes, you could take 4 out, but those are not the highest common factors. You need to take 8 out, as this is the highest common factor of 24 and 8. Now, look at the algebraic components here. We can see there's a common factor of x, which I will take out like that. And that means in the brackets, we are then left with 3 subtract y. And expanding back, we can see this reverts to the previous answer. If you had just taken out a 2 or a 4 or not taken out the x, you wouldn't have fully factorised the expression. So a few examples are going to come up and you're going to have a go at factorising each of these. So here are your 3 expressions. Have a go at factorising each of these completely. Let's check our answers to each of these. So question 3, I'm going to take 2x outside the bracket, leaving me with 2 take away 3x inside the bracket. Question 4, I'm going to take 3a outside the bracket, which leaves me with 2b subtract a inside the bracket. And in the last example, I can take out 3xy, which leaves me with 4x y squared minus 1. And always expand back to check. If I multiply these two together, I will get 12x squared y cubed. If I multiply these two components together, I will get minus 3xy. Let's do one last example together. Put it up here, call it example 6. Let's suppose we have 4p plus 6p squared plus 12p cubed. We've got 3 terms here, but we can still carry out a factorisation. Let's look at the numerical parts first. 4, 6 and 12. Well, the highest common factor there is 2, so let's take a 2 out. And then let's look at each of the 3 terms in the algebraic part, p squared and p cubed. We can take out a p. That leaves inside our brackets 2 plus 3p plus 6p squared. And then you can expand back just to check that you've done this correctly. So we can factorise very simple expressions like this where we have more than 2 terms, but all 3 terms have common factors. And in this case, the common factor of all 3 terms was 2p. So this takes us on to the main part of today's lesson, which is the factorisation of quadratic expressions. So remember earlier on in the lesson when we talked about what a quadratic expression actually is. We said it's an expression where the power that is highest in that expression is a square. So for instance, if we have something like x squared plus 5x plus 6, that is an example of a quadratic expression. The highest power is x squared. Now, we're going to learn how to factorize this. At first glance, this may seem like a strange question because looking at the three terms, there's nothing that all three have in common that's obvious. So x squared and 5x have an x in common as a factor, but 5x and 6 do not have any common factors. So occasionally, when people are asked to factorize an expression like this, I sometimes see something like this written down. So people try and factorize an x as a common factor from the first two terms, and then they just add the 6 on at the end. Well, that is very, very, very wrong. It's so wrong, I'm going to rub it out as quickly as possible, because that's not what factorization means. And we're going to take a small moment as an aside here to remind ourselves of what does factorization actually mean. So if I asked you to factorize 12, I'd be asking you to find me the factors that make up 12. So a possible factorization of 12 is 6 multiplied by 2, and I factorise 12. Another possible factorization of 12 is 3 multiplied by 4. I might ask you to find me the prime factorization of 12, in which case I would be looking for 2 multiplied by 2 multiplied by 3. So factorize means a lot more than put brackets in. That's a very simplistic way of looking at the concept of factorization. Factorization means find the factors. So for instance, if I then asked you to factorize for me 4x, well, 4 and x are the factors. If I ask you to factorize for me 12x plus 6, I know a lot of people will think that means put the brackets in, but not really. It means find the factors of 12x plus 6. It means split 12x plus 6 into a product of its factors. And we know that you can factorize 12x plus 6 as 6 bracket 2x plus 1, which really means 6 multiplied by 2x plus 1. And these are the factors. So 6 is a factor, but so is 2x plus 1. They multiply together to give us 12x plus 6. And that is what factorization means. It doesn't mean put a bracket into something. Quite often brackets are involved in the factorization process, but what it truly means is find the factors of your original expression. So now, let's go back to our quadratic expression, x squared plus 5x plus 6. How do we split this up into a product of factors that multiply together or expand to give us x squared plus 5x plus 6? Well, some of you may already have an idea about how this is going to work because you have seen expressions like this quadratic expression before. Think back to earlier on in the lesson. You did a little bit of work on expanding. So, for instance, remember when you expand an expression like this, x plus 2, x plus 5. What happens? Let's go through it again step by step. So, x multiplies by x, giving us x squared. X multiplies by 5, giving us 5x. X multiplies by 2, giving us 2x. And 2 multiplies by 5 to give us 10. We can then simplify this because in this particular example, the two central terms here can be simplified to give us 7x. And we end up with a 3-term quadratic expression, a little bit like the one we have here, x squared plus 5x plus 6. So that should give us a good indication of how to do the factorization, and it means we need a pair of double brackets like this over here. So to start my factorization, I'll have a pair of double brackets, and my brackets are going to begin with x and x, so that when I do my expansion, x multiplied by x will give me this x squared over here. Now let's turn our attention to the two numbers at the end. Over here we had a 2 and a 5, and they multiplied together to give us a 10 at the end. Now we have, in our example up here, a 6. So we need to find pairs of numbers that could multiply together to give us 6. So there are not that many options here. I could have 2 multiplied by 3, or I could have 6 multiplied by 1. Let's try them both out and see what happens. So I'm going to set up a second pair of brackets, and I'll have x and x here at the start, which we know will give us the x squared term. Now in the first pair, I'll put in a +2 and a +3, and we know that these multiply together to give us the 6 that we want. In the second example, I'll put in a 6 and a 1, because again, 6 and 1 multiply together to give us 6. But only one of these answers is going to be the correct factorization, because there is only ever one true, unique factorization that works. How do we know which is the correct one? We check by expanding. So in the first possibility, when I do my expansion, this is going to give me, if we follow the yellow arrow, a 3x. If I then follow the blue arrow here, that will give me a 2x. We of course already have an x squared and a 6. And it is this combination of the 3x and the 2x that give me the 5x here that I wanted. So the correct answer is x plus 2 bracket x plus 3. Let's just check this second example, even though we know it's actually wrong. If I multiply this x by the 1 here, that will give me a positive x. If I multiply the 6 by the x here, that will give me a 6x. Remember, I already have an x squared and I already have a 6 in place at the start and at the end. But this time, the central terms combine to give me a 7x, which is wrong, because remember, I wanted to aim to get a 5x. So there's only one correct answer. The second attempt that we tried didn't work. But how do we know for sure which is going to give us the correct answer? Well, for the moment, have a look at the 2 and the 3. We know that 2 and 3 multiply together to give us 6, but they also add together to give us the 5 here that we wanted, because it's not just 2 plus 5, it's 2x plus 3x that we have. 6 plus 1 gives us 7, which is wrong. Now, this is a reasonable rule for us to use at the moment. A little bit later on, when you get into year 10, you'll have to learn about some more complex quadratic expressions, and you'll have to do a bit more practice of different factorization techniques that you need to use there. But for the moment, we can use this as a good method to help us factorize expressions. Let's take a look at another example. So we are going to factorize x squared plus 9x plus 20, another quadratic expression. Let's prepare our double brackets. Now, we know that the brackets are going to have to begin with x and x, because that is how we get our x squared term at the beginning, like that. And we know that the two numbers at the ends of the brackets, here and here, are going to need to multiply together to give us 20. So let's think of products that create 20. So one option is 10 multiplied by 2, another is 5 multiplied by 4. We could, in theory, have 1 multiplied by 20 as well. Now, which is the correct option? Well, when the brackets are expanded, we need to make sure that they expand to give us positive 9x. So hopefully you can see that the correct option is 5 multiplied by 4. Let's write those in. So plus 5 plus 4. Let's do the expansion. So follow the arrows. We've already multiplied x by x, that's the green arrow. We're going to multiply x by 4 here, so that gives me 4x. We'll multiply 5 by x here, 5x, and then of course 5 multiplied by 4 gives us 20 at the end. So I can then collect together these terms here, and here is my answer, x squared plus 9x plus 20, which is indeed correct. So let's try another example. So number 3, I've got x squared plus 9x plus 14. So let's prep our double brackets ready. So my first terms are going to be x and x. So we're readying ourselves. X multiplied by x gives us the x squared that we want. Now, my two numbers at the end, they must multiply together to give me 14, but we know that these two numbers have also got to add together to give me the 9 here. There's only one combination that will do this. Can you work out what it is? Yes, it's plus 2 and plus 7. Let's just finish off the expansion by checking it. So x multiplied by 7 gives us 7x. 2 multiplied by x gives me 2x. 2 multiplied by 7 gives me 14. And then I can simplify x squared plus 9x plus 14. And we are finished. Now, a quick question here. We wrote the answer as x plus 2, x plus 7. Could we have written the answer a different way? Well, yes. Multiplication is commutative, so we could have written the answer as x plus 7, x plus 2. So the identical brackets, but we've just switched the order in which they're written down. And if you want to, you can double check by expanding this second version, but it will give you exactly the same answer as previously. So let's look at a few more examples. We need to start making things a little bit more complex. So number 4, we're going to factorize x squared plus x minus 12. Now, we're hopefully now clear that the brackets will begin with x and x, but what have the brackets got to end with? Because they've got to multiply together to create not just 12, but negative 12. And using the rule, the numbers have got to add together to give us 1. So that when we multiply the brackets out, we get 2x terms that add together to give us 1x. So combinations that multiply together to give us negative 12. So we could have 6 multiplied by negative 2, but unfortunately they add to give us 4, so that doesn't work. We could have negative 6 multiplied by 2, but that gives me negative 4, so that doesn't work either. Now, what about if I have negative 4 multiplied by 3? Well, that gives me negative 1, so that won't work either. So what can I change now? 4 multiplied by negative 3. Well, 4 add negative 3 gives me 1. So this is the combination that I want. So one of my brackets has got to be x plus 4, and the other bracket has got to be x subtract 3. Final check, just to make sure we've done this correctly. X squared minus 3x plus 4x minus 12. And hopefully you can see straight away the central terms here combine to give you the plus 1x, or just the plus x there. So we've done this correctly. Now, the only other way that you could present a correct answer here is to swap the brackets and have x minus 3 written first and then x plus 4 written second. So can you see this is the identical pair of brackets we had in our answer up here? We've just switched the order. You cannot change the signs. So for instance, if you tried x minus 4 and x plus 3, so I've actually swapped the signs this time, you would get an answer of x squared minus x minus 12 when you do the expansion, and that is of course wrong. So be very careful with your answers. Let's do another example. So number 5, we've got x squared minus 4x minus 5. So open our brackets up, ready? X and x. Now my two numbers that I am trying to locate will have to multiply together to give me -5, and they've got to add together to give me -4. Can you work out the pair of numbers that we need here? So you should hopefully spot if you have -5 multiplied by +1, that will give you -5, and -5 add +1 will give you -4. That's the only combination that will work. So x minus 5 in one bracket and x plus 1 in the other bracket as ever. We'll finish off with a final check just to see that we've done this correctly. So x squared plus x minus 5x minus 5, and this simplifies to give us x squared minus 4x minus 5 at the end. So we're going to finish off with just a few more examples, just to really make sure we've all understood this. Let's factorise x squared minus 8x plus 15, an interesting one. So what do my two numbers need to multiply together to make? They need to multiply together to make positive 15. What do they need to add together to make? They need to add together to make -8. So how do I find a pair of numbers that multiply together to give me a positive number, 15, but add together to give me a negative number, which is -8? Think about this. And of course, it means that both numbers have to be negative numbers. So there's only one pair of options here, -5, -3. Stop and think about them for a minute, check you're happy that they both multiply together to give me positive 15 and they add together to give me -8. So here we have x minus 5, x minus 3. You can do a quick check again, multiplying out my pair of brackets, and hopefully just finish off by convincing yourself that we've done this correctly. So there in the centre is our -8x, and we have done this correctly. Let's look at another example. X squared minus 6x plus 9. So our pair of numbers have got to multiply together to give me positive 9, and they've got to add together to give me -6. So what pair of numbers will do that? Stop and think for a second. How will you find two numbers that multiply together to give me a 9, add together to give me a -6? Well, again, it's two negative numbers. -3 multiplied by -3 gives you positive 9, -3 add -3 gives you -6. So let's complete the brackets, x minus 3, x minus 3, and you can expand and check that yourself to verify this. Now you may like in this example to write your answer in a slightly different way as x minus 3 all squared. And now you've seen this process in both directions because we have taken expressions like this, written them like this, and expanded to get answers like this. We're now doing all those steps in reverse. Have a go at the next one yourself. So we have x squared plus 4x plus 4. Can you factorise that into a pair of double brackets? So hopefully you've seen that the two numbers have to multiply together to give me positive 4. They've got to add together to give me positive 4. So my only possible combination is x plus 2, x plus 2. So we're going to finish off by you having a go at 5 examples. In each case, we will have a quadratic expression. Can you factorise each of these quadratics into the corresponding pair of double brackets? So once the questions come up, make sure you pause the video, have a go yourself, and then the answers will come up afterwards. So let's see how you got on with these. Question number 1. We needed to find two numbers that multiply together to make 12, add together to make positive 7. So you should have found you have x plus 3 in one bracket and x plus 4 in the other bracket. Remember, you can reverse the order of the bracket, so if you wrote down x plus 4, x plus 3, that would also be correct. The signs must be the same regardless of the order of the brackets. Question 2. Two numbers that multiply together to make 30 and add together to make 11. So that has got to be x plus 6 multiplied by x plus 5, or x plus 5 multiplied by x plus 6 in the other order. Question 3. Two numbers that multiply together to make negative 14, add together to make 5. Did you get it right? It's x plus 7 brackets x subtract 2. Now the only other correct answer here would be if you wrote down x minus 2 first and then x plus 7 second. So you can see in both examples we have a positive 7 and we have a negative 2. It's the order of the brackets that's been changed, not the signs of the terms inside the brackets. Number 4, we need to find two numbers that multiply together to make negative 20, add together to make negative 8. It's x minus 10, x plus 2. It has to be that way round. It has to be a negative 10 and a positive 2. If you got those the wrong way round, check your expansion. You will end up with positive 8x, not negative 8x. And the last example, two numbers that multiply together to make 12, add together to make negative 8. It has got to be x minus 6, x minus 2 to finish off in your factorization.